Okay, in this video we'll discuss the how to handle the continuous random variable and what are the basic definition that we have discussed for discrete variable that we're going to discuss for continuous random variable. In a continuous random variable, probability density function is continuous as shown in the figure. So here I have given you one figure and let's say the height of this maximum height equals to k. Now we can find out this value of k using our function properties. It is known that the area of this graph is always equals to 1. The probability of all outcomes is equals to 1. Integral of fx dx equals to 1, which is nothing but the area under this graph. So this figure is consist of three standard figures. One is triangle, rectangle and one triangle. So we can calculate this area as area A1, A2, A3 and the sum of all this area must equal to 1. So we have A1 plus A2 plus A3 equals to 1. Area of triangle is given by 1 by 2. Base is equal to 1 and height is same as k. So 1 by 2 into 1 into k plus area of this rectangle is 3 minus 1 is equal to 2 is the base and k is the height. So 2 into k plus area of third triangle, base is 1, height is k. So 1 by 2 k multiplied by 1 is equal to 1. So if we solve this, we will get the value of k and the value of k is equal to 1 by 3. So using the simple computation of integral fx dx, we can calculate unknown value of k and this value of k is equal to 1 by 3. Now once we know the value, how to calculate value of k, now how to find out the probability. So basically it starts from minus infinity and then it is defined from 0 to 1, 1 to 3, 3 to 4 and 4 onwards the value is equals to 0 of a function. So for minus infinity the px equal to 0 and x greater than 4 your value of function is equal to probability px equal to 0. So basically px, that is the probability, is nothing but the area under the curve and is given as integral a to b. So we are interested from a to b fx dx. So if you are interested what is the probability at x equal to 1. So exactly at x equal to 1, it means that your upper limit and lower limit will equal to 1. So from 1 to 1 fx dx. When the upper limit and lower limit is same, your answer will be equals to always 0. It means that you can't find out exact value of probability at x equal to 1. So this is not defined. Area under this line is not defined. Or if you want to find out what is the probability at x equal to 1.28. So even this value is also equal to 0. Because this time also you have to integrate from 1.28 to 1.28 fx dx. This is also equal to 0. Whereas in the case of discrete, we can very well define x probability at x equal to 0, x equal to 1, x equal to 2 like this. But this is, we can't define this value in the case of the continuous random variable. Because if we try to define the continuous random variable probability at any particular value, then that will always equal to 0 because upper limit and lower limit will be same, then the probability will be 0. But we can very well define for two different value of x. Suppose we are interested from what is the probability from x less than equals to 2 less than equal to 3. So if you are interested from 2 to 3, it means that we are interested from the area 2 to 3, that is this area. So area under this diagram represents the value of x in between 2 and 3, including 2 and including 3 also. So this area will be equals to 1 into k because 3 minus 2 is 1. So 1 into 1 by 3 is 1 by 3. But even it doesn't matter whether you take 2 or you does not take 2 or you take 3 or you does not take 3. That is, if you want to find out probability for 2 less than x less than equals to 3, even then your idea will remain same. This time 2 is not included. So we have 3 included but 2 is excluded. Still the limit will remain same. So this is still equals to 1 into 1 by 3. Even we take probability of 2 less than equal to x less than 3, the meaning remains same. That is, we have the same area in the figure. So area remains same, the probability is also remains same. So whether number is included or number is not included does not matter for continuous random variable. Even for third situation, if the probability is 2 less than x less than 3, even then our area is always remain same. That is the same hatch area. So all these answers will have same meaning. So A and B, whether they are included or not included, doesn't matter. Is same as P, probability of P 2 less than x less than equals to 3 is same as 1 by 3. All these answers are one and same. So please note here that the value are totally inclusive or exclusive and does not matter. Whether we have upper limit or lower limit is inclusive or exclusive does not matter for us. Suppose we want to find out the limit of P 0 less than x less than equals to 2. So this time we are interested this total area from 0 to 2. Now we can calculate this area in two steps because of one triangle and one rectangle. So the area of the triangle will be 1 by 2, base is 1, height is k 1 by 3, base and height is k 1 by 3. Second is this base 2 minus 1 is 1 and height of rectangle is 1 by 3. So this answer is 1 by 6 plus 1 by 3. So we have 6, 2 plus 1, that answer is 1 by 2. So this is how you have to handle the continuous random variable. Let's make a difference between discrete and continuous random variable. The mean value or expected value, that is mu is equal to E of x, is simply given as x into f of x or p of x. Whereas in the continuous random variable, the same value is obtained by integral x into f of x into dx. So this is a slight difference. In a discrete you have to use the symbol sigma. In continuous you have symbol integration. The variance which was given as sigma square. In the case of discrete random variable, this value is given as x minus mu whole square into p of x. Almost same thing repeat in continuous random variable, x minus mu whole square into p of x into dx. The standard deviation is under root of variance. Now the difference of calculation of the probability. So we have a graph of continuous PDF, the probability density function. The graph is valid from, if you are interested, from x equal to a to x equal to b. This is a continuous graph. Whereas in the case of discrete random variable, we have a bar chart like this one. So it is not a continuous, rather it is discrete. So on y-axis we have probability, on x-axis we have x. The property of this one is summation of all possible outcomes, that is sigma px is always equals to 1. Now the same property that will be applied to continuous random also, but in the integration form, is px multiplied by dx, and this sum is always equals to 1. In the case of discrete random variable, we can very well find out the probability at x equal to 1, x equal to 2. That is exact value at x equal to 2 is possible or x equal to 3 is possible. But the same practice if we preferred in a continuous random variable and we try to find out the value exactly at x equal to c, so area under the vertical line will always equal to 0. This is the major difference between the continuous and discrete. So probability at x equal to c is integral from c to c of px into dx, and this answer is always equals to 0. But we can very well define the probability a less than equal to x less than equal to c. This probability is represented by this area. So if the standard area is known, you can calculate that, and if the function is known, then you have to integrate this value. Is limit from a to c of px into dx. Now this will be definite value. Now it does not matter whether you take the limit, whether inclusive or exclusive. That is, probability of a less than x less than equal to c is same as the probability of a less than equal to x less than equal to c, or is same as probability of a less than equal to x less than equal to c. So including or excluding does not matter. And if you want to calculate the probability c less than equal to x less than equal to b, so you have to take the area from c to b. So that is this area. So this area represents the probability of c less than equal to x less than equal to b. That can be obtained by method of integration if the function is known. So is integral from c to b fx into dx, and is same as the limit including or not including, that is probability of C less than X less than B also. So this is a major difference between the discrete and the continuous random variable. Use this property because problem will always appear on this theory.